Hey YouTube, welcome to Higher Math Solutions. This video tutorial is going to go over how to graph and eliminate parameters for parametrics. A parametric is two types of equations, a horizontal and a vertical equation in terms of a parameter. It could either be t as in time or it could be theta as an angle. So what we're going to do is our first example, we'll do one in terms of t. So here are two equations in terms of x and y. Here's a horizontal equation in terms of time, as is y, and we're going to go over how to graph these first. To be able to graph a parametric equation, it is best just to do a t-table. You're going to pick values of time, make sure to pick negatives as well as positives, and stick within the domains of the inputs of the function. So let's start with -3. You're going to take a time -3 and you're going to go plug it into the x and y equation. So if I plug it into x, I get -2, and if I plug it into y, I will get 3/2. Next, you can just pick another one, so I'll pick -2. If I plug it into x, I get -1. If I plug it into y, I will get -2/-1, which will reduce to 2. And then I'll pick -1. If I plug -1 into x, I'll get 0. But if you plug it into the y equation, you actually get an undefined, and that tells you that you're actually going to have a vertical asymptote at that value. And then make sure you pick some positives as well. A 0 is always a good one to try. You'll get 1, 0 in that case. And then if you picked t equals 1, you'll get 2/1/2. And then I'll do one more. I'll put in t equals 2, so I'll get 3 and then 2/3. Again, make sure that you have a really good range of different t's that you can get a really good graph. It's also important to graph them in the order that the time goes in, because you'll also have to indicate the direction the particle is moving. So then you just go and make your xy plane. And then you can plot the xy points from your table. So I have -2 and 1.5. And then I have -1, 2. And then at 0, instead of plotting a point, I'm actually going to put a vertical asymptote there. And then at 1, I'm at 0. 2, I'm at 1/2. And 3, I'm at 2/3. The more points you have, the better that you can indicate what your graph will look like. But in this case, this is giving us a rational graph. And I can just connect the points that I drew, but I do know that it is going to continue on in that fashion as well. So it will look similar to a rational equation. And then I will draw in the arrows. I am moving towards the left, so my particle is moving. I'm sorry, that's towards the right. And so you will have to indicate the direction that the particle is going. So make sure that you are graphing them in order. To be able to get what this equation is in just terms of x and y, you can what we call eliminate the parameter. Eliminating the parameter will get y in terms of x, and it will eliminate the t. There are two steps. Step 1 is to solve for t in the x equation. And so this one is not too hard. You just subtract the 1 over. And step 1 is done. And then in step 2, you're going to do substitution. You're going to sub the t equation from part 1 into your y. And so I'm going to plug in x minus 1 wherever I see a t. And you can do a little bit of algebra by combining like terms. And then there is your equation in terms of y. Now you do also have to list any restrictions that you have. In this case, you do see that the denominator is 0 at 0, and you also saw by the graph that we got a vertical asymptote at 0 as well. So you do have to indicate the restriction that x cannot equal to 0. And if you were to graph this on a separate plane, you would see that it is exactly the same graph as the one that we just drew. Let's look at the ones in terms of theta. Parametrics also have a relationship to conics. And in this case, you can make your table with theta, x, and y, but what you'll end up realizing is that this is a pretty common conic. And if you make your table, you can just stick with your quadrantals. And you can see what you end up with. So if you plug in 0, you get a point, but I want to show you a shorter way to do this. Let's actually eliminate the parameter first so you can see what you end up with. And in this case, it's a different steps than with the t's. You're not going to solve for theta in the x equation because that will involve inverse trig. So what you're going to do is you're just going to solve for cosine, and then in the y equation you'll solve for sine. And the reason that you're going to do that is because we're going to use an identity. So if I solve for cosine, you're going to subtract the 3 over, and then you'll end up dividing by 2. And to solve for sine, you'll add the 1 over, and then you'll end up dividing by the 3. And to eliminate the parameter, this one we're going to use the identity of cosine squared plus sine squared equals to 1. And you're just going to fill in what cosine and sine are. So in this case, we have x minus 3 over 2 squared plus y plus 1 over 3 squared equals to 1. And you should have already gone over conics, but if not, then you need to review that. But this is an ellipse. You can reduce it a little bit more by squaring the denominators. And then you see here, you do get this ellipse equation, and it is pretty easy to graph here. Your center is at 3, -1, which if you look at the original parametric equation, your center is located with the constants, so 3, -1. And then this 4 indicates the b value, and you need to square root it, so, or you can think of it as the number before you squared it. So you go out on the x2, and then on this one, you'll go up on the y and down on the y3. And then you have your ellipse. If you wanted to graph the direction, the angles go counterclockwise. So you will end up with a graph that looks like this. But if you have a cosine and sine, then you will always end up with an elliptical type conic. If these end up getting squared, then you can end up with a parabola or something a little bit different. But you can always eliminate the parameter, and then you can see exactly what you end up with. Let's do one more theta so you can see one more type of conic relationship. Here's one that is involving tangent and secant. Again, this if you wanted to start out doing a table, it'd actually be pretty difficult. The quadrantals don't really give you enough information, and this one actually ends up being what we call a hyperbola, and so it's just not very easy. So it's actually best to be able to just to recognize what it is. If you have a tangent secant, you're always going to end up with the same type of parametric, which will end up being the conic. In this case, we are going to end up using another identity, but we'll use the one that involves secant and tangent. And so what you need to realize is that the secant one is always your positive one because the identity is always in this order. So this can interchange. X and Y don't have to be one or the other, but in this case, secant is with the Y. So your Y will always go first in this situation. So you're going to do the same thing. You'll solve for secant by adding 2 over. And then you'll also solve for tangent by subtracting 1 and dividing by 3. And then you can go plug them into the identity. So secant squared minus tangent squared equals 1. So again, remember, the secant always goes first. Again, this is related to conics. Here is your eliminating the parameter equation, and recognizing just what to do from here is very helpful. So in this case, our center is still -2, 1, as you can see. The center is still the same as the cosine and sine one, where it is your constants in the front. So if you graph this, you have the graph of 1, -2. That's your center. Since the y value is first, this is a vertical hyperbola, and I will end up going, since it's divided by 1, I'll be going up 1 and down 1. And then also, the x is over 9, and so your b value will be over 3 and to the right 3. So these are your vertices, and the reason that you need these right here is you can make a box with the points that you drew. And these will end up being vertical asymptotes. And then your parabolas will follow the asymptotes. And then that is what your graph looks like for this parametric. Thank you for watching Higher Math Solutions. See you next time.